You've probably heard the name Albert Einstein. It's practically a synonym for genius, right? But what did he actually do that was so revolutionary? Beyond the iconic image of wild hair and a playful tongue, Einstein gave us one of the most powerful ideas in human history, the theory of relativity. It didn't just tweak a few scientific equations, it completely tore up the rulebook for how we understand time, space, and reality itself. In this video, we're going to dive into how Einstein's mind-bending theory reshaped everything we thought we knew, and why it's more relevant today than ever before. Let's rewind to the early 1900s. Physics was feeling pretty confident. Isaac Newton's laws had been ruling for over 200 years, explaining everything from a falling apple to the orbit of planets. The universe seemed like a giant, predictable clockwork machine, but a few cracks were starting to show. Tiny, nagging inconsistencies that just didn't fit. For instance, light was a real troublemaker. Sometimes it acted like a wave, other times like a particle. And the weirdest part? No matter how fast you were moving towards or away from a beam of light, its speed always measured the same. This was a huge puzzle that stumped the greatest minds of the time. Einstein realized that if the speed of light is always the same, then something else must be changing, and that something was space and time. He proposed that space and time aren't separate, rigid concepts. Instead, they are interwoven into a single, four-dimensional fabric he called spacetime. And this fabric isn't fixed. It can be stretched and warped. It's been proven with ultra-precise atomic clocks on airplanes and even satellites. In fact, the GPS on your phone wouldn't work without it. The satellites orbiting Earth are moving so fast that their clocks tick slightly slower. Engineers have to constantly adjust for Einstein's theory to keep your map directions accurate. Without relativity, your GPS would be off by several miles every single day. But Einstein wasn't finished. 10 years later, in 1915, he unveiled his masterpiece, the general theory of relativity. This time, he tackled gravity. For centuries, Newton's view of gravity as a mysterious force pulling objects together was the gold standard. But Einstein offered a completely new perspective. He said gravity isn't a force at all. Instead, massive objects like the sun and Earth actually bend and curve the fabric of spacetime around them. Think of it like placing a heavy bowling ball on a stretched-out rubber sheet. The sheet sags and curves. Now, if you roll a smaller marble nearby, it won't be pulled by the bowling ball, but will instead follow the curve in the sheet. That's gravity. Planets orbit the sun not because they are being pulled by a force, but because they are following the straightest possible path through the curved spacetime created by the sun. In 1919, during a total solar eclipse, an expedition led by astronomer Arthur Eddington observed starlight bending around the sun. Exactly as Einstein had predicted, the discovery made front-page news worldwide, and almost overnight, Albert Einstein became a global icon, the face of modern science. Fast forward to today, and relativity continues to pass every test we throw at it with flying colors. Perhaps the most spectacular confirmation came in 2015. Scientists at the LIGO Observatory detected something Einstein had predicted a century earlier, but thought would be impossible to ever find: gravitational waves. These are literal ripples in the fabric of spacetime, created by cataclysmic cosmic events like the collision of two black holes billions of light years away. For the first time, we didn't just see the universe, we heard it vibrate. It was a monumental achievement, opening a brand new window to the cosmos and proving once again the profound power of Einstein's imagination. The impact of Einstein's ideas goes far beyond physics. It seeped into our culture, influencing philosophy, art, and the very way we perceive reality. The notion that time is not a universal constant, but something personal and relative challenged long-held beliefs. Science fiction writers had a field day with concepts like time travel and warp space. He warned that our scientific advancements must always be guided by a strong moral compass, to serve humanity rather than to threaten it. Even today, Einstein's work continues to shape the frontiers of science. There is one big puzzle left: relativity, which describes the very large, doesn't quite mesh with quantum mechanics, the theory of the very small. Finding a single theory of everything that unites these two pillars of modern physics is the holy grail for scientists today. It was a dream Einstein pursued for the last 30 years of his life. Though he never found it, his quest continues to inspire a new generation of thinkers, dreamers, and explorers. So, the next time you use your phone's GPS or look up at the night sky, remember Albert Einstein. His theory of relativity teaches us that reality is far more strange, flexible, and beautiful than it appears. He didn't just give us a new set of equations, he gave us a new universe. He showed us that one curious human mind can fundamentally change how we see our place in the cosmos. His legacy isn't just a chapter in a history book, it's the blueprint for our future, constantly fueling our desire to explore, to understand, and to reach for the stars. Thank you so much for watching. If you enjoyed this journey through spacetime, don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next adventure. See you next time.